Okay, welcome to part 4, lecture on aquatic biodiversity. This is section 8.2 and 8.3 out of the Light textbook. First thing we want to talk about is that oceans actually provide enormously valuable ecological and economic services. And then if you look over here, the estimated value is about 12 trillion per year, and that's actually equal to the annual U.S. gross domestic product. So if you look at some ecological services, we have climate moderation, carbon dioxide absorption, nutrient cycling, waste treatment, reduced storm impact because of mangrove forests, barrier islands, coastal wetlands, and then habitats and nursery areas, genetic resources and biodiversity, and scientific information. We actually know more about the surface of the moon, they say, than about the oceans. And according to the aquatic scientists, the scientific investigation of poorly understood marine and freshwater aquatic systems could yield immense, even more benefits. Um, let's see. Oceans provide important ecological and economic resources. They are reservoirs of diversity. And when we say reservoirs of diversity, we mean species diversity. They help with allele frequencies and genes found in populations, and then biological and chemical processes as well. The coastal zones actually have a very high NPP. Pretty much the amount of photosynthesis per unit area is high in the coastal zones. And then we'll talk about the open sea, and we will discuss the ocean bottom. So, like the biomes that you learned, the terrestrial biomes, they're usually categorized by dominant plant growth forms. Aquatic biomes are going to end up being categorized by physical characteristics like the salinity, the depth, and the water flow. So natural capital, major life zones, and vertical zones in the ocean. From this picture here, you can see some of the different zones. We start out with the coastal zone over here, and the coastal zone is going to have the highest NPP. But as soon as you leave, by the way, this is not drawn to scale. But as soon as you leave the coastal zone and you head out to the open sea, we now are going to distinguish each layer vertically this direction. And just out of curiosity, I'm wondering, what does this kind of remind you of, since we have some distinct vertical layers here? What does that remind you of? What other biome do we say has layers? Excellent, great job. You probably said it reminds you of the tropical rainforest and the stratification because of the different layers that you see. But anyway, so when you're in the open sea, it is actually divided by the amount of sunlight that the zones get. So there's 3 zones. We're going to start out with euphotic. So if you think of photic, you should think of light. Photosynthesis, that is obtaining energy using light. So photic, this is going to be this area in the zone where you have a lot of sunlight. Bathyl zone is going to have less sunlight, and then abyssal will have almost none. And then we'll talk about some of the unique adaptations each of those zones that critters that live there will have. Coastal zones, warm, nutrient-rich, shallow, ample sunlight. Let's see, from high tide to the edge of the continental shelf, it is less than 10% of the area, but over 90% of the species live in the coastal zone. And then we have estuaries, and we'll talk about estuaries more in a second because I love estuaries and coastal wetlands and tidal zones. So hopefully some of y'all are already thinking about our trip to Skidaway, because Skidaway is a barrier island where we will be playing in an estuary. It's a part of the Georgia coastal wetland, and we're going to be walking along an intertidal zone. So hopefully you're already thinking about coming. Okay, so estuaries. This is the area where the river meets the sea. It is brackish. So it's not going to be, it's going to have a different salinity than the ocean. It would have a lower salinity than the ocean, yet it would have a higher salinity than the freshwater rivers. And basically what happens is you'll see, in a minute I'll show you a picture, you'll see a big plume of sediment, and the plume of sediment basically makes the water more turbid. It creates more turbidity. What's also neat is that with estuaries, they're also, since it's river runoff, a lot of times it's going to have a lot more nutrients, and because of the extra nutrients, you're going to have a lot more algae, and you're going to have a lot more plant life in those areas. So usually your estuaries, basically your river mouth, We can call them inlets, bays, sound. And in the temperate ecosystem, which is where we live, so when you go to Skidaway, you're going to see salt marshes, and salt marshes have characteristic seagrass beds. And then in the tropical areas, you'll have mangrove forests, and the mangrove forests are very significant. They help, both salt marshes and mangrove forests help with reducing storm damage. But seagrass beds support a variety of marine species, stabilize shorelines, and reduce wave impact. And seagrass beds, the ones you'll see off the coast of Georgia and Skidaway, it's typically called Spartina grass, and it has many uses. It's used, first of all, it helps to filter out some of the toxins that come from the Savannah River that are dumped into the bay there. And it filters out toxins, and it's a place where animals from the sea and terrestrial animals, by the way, aquatic and terrestrial animals, will come and they will spawn there. They'll lay eggs, they'll come back later. And then they also help to reduce the wave impact. Okay, so let's see some components of interactions in salt marsh ecosystems in a temperate area. And this is unique because this is where we live. And seagrass beds, they're pretty cool because they have at least 60 species of plants that grow underwater. So they've actually adapted so where their roots can be consistently underwater. And they, again, help to stabilize the environment. Oh, here's an example of the plume. You can see this is an estuary from space. This one actually is in Madagascar, and you can tell where the riverbed ended up dumping the sediment into the ocean. Okay, let's see. Important ecological and economic services of estuaries and coastal wetlands. Coastal aquatic systems maintain water quality by filtering. That is huge. They filter toxic pollutants, excess plant nutrients, and you'll soon learn that we have a lot of excess plant nutrients in our water systems nowadays. And then it also helps to filter out some of the sediments. And then it absorbs other pollutants, provides food, timber, fuel wood, and habitats. So at one point, especially the mangroves, they were used sustainably to provide timber and fuel wood. Unfortunately, now though, they are no longer being used sustainably, so they are affecting the storm control that they used to provide. They are no longer providing it because they're cutting down too much of it for fuel wood. And definitely provides habitats for many, like I said, marine and terrestrial ecosystems. Reduce storm damage and coast erosion, and then here it says loss of mangroves lead to saltwater intrusion. So remember, we no longer have that basically will mean that you will lose your fresh drinking water along the coastal areas because you are now losing the root system and the pressure that the mangrove forest was providing. Okay, so this is an example of what it looks like. And what's cool about these trees is they are actually adapted to be submerged completely. So their roots can be submerged completely underwater, and their roots end up growing above water, and that helps them to achieve to obtain some more of the carbon dioxide. Let's see, rocky and sandy shores host different types of organisms. Tides, they are caused by the gravitational pull of the combination of the sun and the moon. Happens about every 6 hours or so. In order to actually live here, though, you have to have very unique organisms that are adapted because the salinity changes frequently, the moisture changes frequently, and the temperature changes frequently. So they have to either be able to hide, burrow, they have to be able to latch on if the water is going to low tide. What's also important is that after the water goes to low tide, they have to be protected from the extreme temperature change. Because remember, water has a high specific heat, which basically means that it's immune to, or it doesn't fluctuate in temperature as much as, let's say, the hot sand, the quartz that is found in sand. But these intertidal zones are very important because the sand dunes help to prevent erosion. So that's significant. You've probably been to a beach where you see a sign that says, if you walking on sand dunes, $500 fine, etc. They take that very seriously because if you walk on the dunes, it's hard to grow roots in sand as it is. And so if plants have been able to form root systems in these dunes and then you go trample on them, then you are losing a huge amount of protection that those dunes provide in case of storms and hurricanes. And so also you have to think about the significance, especially we live on the coast on Georgia. We have more of a sandy shore, barrier beach. because you have rocky shores, which are more like your west coast beaches, and some, of course, some north. But we have a lot in Georgia. Our coastal plains lead to our barrier islands, so we have a lot of sandy shores, and so we're building all over the place. We're knocking down the natural barriers, and we're putting condos, condominiums, apartments, whatever, on the shores. And so you got to think about the repercussions from that. We're getting rid of the natural storm system that we had in place. Here's some example again. Sorry, living between the tides. If you go to Skidaway, we will be going at low tide. Therefore, we get to kind of walk along the beach. Because notice, we're down here. We're more of a barrier beach. Skidaway Island is a barrier island. And we'll get to actually take our shoes off and get to walk up and down the beach and collect some of these specimens, some of these organisms that live in the intertidal zone. And then we'll form a big circle, and then we'll sit there and try to do some identification of what these are. If anyone's been to Laguna Beach, this one up north right here, the Rocky Shore Beach, that looks exactly like Laguna Beach. And they have actually created preserve out there where they don't want you to like step on it and pull the organisms out, but they do have a few paths that you can follow to look at some of their organisms. Primary, secondary dune, this is an example here. So typically what you're going to want to do, like let's say this is Skidaway, you will have an ocean side, and St. Simons, same thing. If you've been to Jekyll Island, St. Simons, Tybee Island, you'll have an ocean side, and then you'll have the intertidal zone over here. You'll have the bay side pretty much, and it's best to build over here because you don't want to mess up the storm control that this primary dune will have for you. But what's interesting to note, the Atlantic Ocean, it has a current that comes down at kind of a southwest angle. So the current comes down at southwest angle, and it is basically stripping if you have a beach to the north, it's going to eventually shift and take that sand and move it south. And so people will build barriers to try to, and they call them, I can't remember what they call them, but anyway, they build to try to trap the sand so it won't go further down the beach, and that just makes the people south ticked off because they have to bring sand in then when that happens. So barrier islands aren't stable. They're constantly shifting. So you have to think about the repercussions of building homes on a piece of land that is obviously going to be prone for wind erosion. Coral reefs are amazing centers of biodiversity. So this is the marine equivalent of tropical rainforest in terms of biodiversity. It's the habitat for 1/4 of all marine species. And the way the coral reef works, it's actually a symbiotic relationship between a polyp and an algae. And so what happens is that the algae uses carbon dioxide. Yes, so the algae uses the carbon dioxide and through photosynthesis provides oxygen and food for the polyps, and in return the polyps end up providing the algae a home, a safe place to live. And one of the byproducts of the relationship, the algae are what makes the coral a really pretty color, and one of the byproducts of the polyp is that it creates a calcium carbonate. In other words, it's like a limestone exoskeleton. And what's been happening lately is that the algae is dying off because of changes in acidity of the ocean, because the burning of fossil fuels mixes with water, kind of creates a chemical reaction. And so the acidity is killing off some of that algae. And so you're seeing something that they call coral bleaching, because the coral is turning white because you're basically just seeing the calcium carbonate from the polyps. So that's been problematic. And the reason that's significant is because, like I said, they not only are habitat for 1/4 of all marine species, but they also act as a natural barrier as well. Along about 15% of the world's coastlines actually are going to be protected from the coral reefs. One of the most famous coral reefs is actually found the Great Barrier Reef, and it is off the coast of Australia, and it's huge. It covers about 1,600 square miles, and a lot of biodiversity there. You can find fish and vertebrates. They use it as a refuge, and they live there. They find food there. So the limestone too is pretty cool. The skeletons will accumulate, and that's what makes the reef build over time, because then the next polyp is going to live on a piece of the old calcium carbonate, and that's how it gets so big. So anyway, so the coral bleaching phenomenon has actually been very, very problematic, because if the coral all dies off, then we're basically going to lose homes for many, many species. Okay, vertical zones. Okay, so talk about this already a little bit. How once you leave the coastal zone, and by the way, the coral reefs are only going to be on the coastal zones because they have to have a specific amount of sunlight. So the farther you go into the open ocean, they also obviously are building off the ocean floor. So it's got to be